Indices sounds a lot like in the seas. Fish are in the sea, and if there are plenty of fish in the seas, why am I still single? That was kind of a dark joke. We mentioned that strings can be thought of as an ordered collection of characters, and you might think that you can access specific characters on a string using something like this. Right, we would think that'd be the old L. Am I right or am I right? The code right here, stubborn with the subscript of 3, is using the subscript syntax. So for the most part, these brackets indicate that you're using a subscript in Swift. Subscripts allow us to retrieve a specific value within a collection. And if you thought that this syntax was right, and you thought that right out of the box, you could be right. You have the potential to get a 10 out of 10, and you could receive all of the gold stars. But do you think you're right? Do you think you're right? 3 right here is an index that is used to find a specific element within a collection. This code suggests that we are trying to select the 4th character from the collection of characters that make up the stubborn string. Wait, Nick, you're an idiot. You just said 4th. Nah, fam. The first index starts at 0. Gosh, why would you ever question me? Since we tried to use a subscript, we get this error. Subscript is unavailable. Cannot subscript string with an int. See the blah blah blah. That's fine, whatever. Swift is all mad because the compiler won't let us access a specific character on a string via a subscript index. This limitation, this error, has to do with the way Swift strings and characters are stored. We can't index a string with an integer because Swift doesn't know which Unicode scalar corresponds to a given index without stepping through every preceding character. Swift is so silly. This operation can be expensive, so Swift wants us to be a little more explicit. Not like rap album explicit, but fairly explicit. By the way, Logic's album dropped the other day. Who's bumping that? Alright, sorry, off topic. Swift uses a type called string character view index to keep track of its indices. And this just means that index is a type that is defined on character view, which is a type defined on string. The type character view is responsible for giving a view of a string's characters as an ordered collection. As you saw in the last, that was my dog sneezing, I don't know if you heard that. As you saw in the last few videos, an individual character can be made up of multiple Unicode points. It is the character view's job to represent each of these code points as a single character instance to combine these characters into this correct string. And we like having index defined on character view because it allows us to ask the character view to hand back indices that are meaningful for the string in question. For example, if we wanted to, let's make some room here. If we wanted to find the character at a particular index, we begin with the string type's start index property. Hey, none of that. And then we have character index dot index. This property yields the starting index of a string as string dot character index dot index. We can use this starting point and some teamwork with this method right here, that method, to move forward until we have arrived at the position we want. Does that make sense? And if it doesn't, I'm going to show you and it's going to make sense. Let's try to find the 5th character in the stubborn string. Let's also comment this out because it's going to be mad the whole time. So let's create a constant called start, and this is equal to stubborn.start index. That seems simple enough. And let's have end equal to stubborn.index. We're going to use that method I was talking about, start, which is the starting point, offset by. Then we're going to set the 5th character, which is what we were searching for, equal to stubborn, and that should be O. We use the start index property. What are you mad about? Don't be mad. Oh, dope. We use the start index property on the string to get the first index of the string. We use the index method with an offset of 4 method to advance from the starting point to our desired position. The offset by parameter takes an argument of type int, which the method then adds to the first index. We passed in a 4 to represent the 5th character. The result of calling this index method is a string.characterView.index that we assign to the constant end. Then we use end to subscript our stubborn string instance, which results in the character O being assigned to the 5th character. Does that make sense? We took the starting point, we said how deep we want to go, and then we got that character. That's literally all it was. Moving on. on, ranges, similar to indices, depend on string.characterView.index type. Imagine that we wanted to grab the first 5 characters of stubborn, and we can use the same start and end constants. So we could do let range equal start ... end. And then we could do let starters equal stubborn range. The reason I call it starters is because that's the first 5. Hello, that's nice. And you see how it says closed range here? The start and end range is what that closed range is. And I think you can see exactly what it does. You are finished with the string segment. Congratulations. I'm happy that you are finished with it as well. This was a lot of material and information and you did great. Hang in there. Next up is optionals, and that is something you don't want to miss because they come up a ton when programming in Swift. I love you, and I will see you in the next video. Please subscribe.